Here's a couple of questions from section 5.3. First one has to do with graphing. Second one using a formula for decibel to find the loudness of a sound. First off, you're asked to compare how these graphs or how they compare with a basic graph. So what we're comparing them to is f of x is equal to log base 2 or 3, whatever the base is, that doesn't matter, of x. Now, if you remember back in section 2.5, we had a formula that looked like this. A f of bx minus c plus d, something like that. And each one of those had a specific effect or transformation on a basic graph. So with a log graph, we have a similar one. We could write it like this. Um, f of x is equal to a log, whatever the base is, that doesn't matter. We'll say 2, of bx minus c plus d. Now, b is typically a funny one. We'll talk more about that in trigonometry and play with it more there. But usually we play with a, c, and d. Anyway, so this is the basic transformation function for logs. So I have to take a look to see what position this number is in. So for 83, this is a change over this. And that thing is in, looks like it's in the C position. So this graph here is going to move, and C is the left-right guy. So C, or this graph here, uh, for the transformation, I would say this graph would move. And if it's positive, it's opposite to what you think. So this one, I would say it would move left by a factor of 3 units. Now you can graph these on your graphing calculator, typically a log function. Let me just graph one. Whoops. I can actually get a chart there. Okay, so here's a graph. Typically the log function looks something like this. Goes up and like that. It's not perfect, but it's close. So this graph, if it's moved left 3, then it's going to be look like this. Uh, Again, it's not perfect, but it's something like that. Now, if you want to be a little bit more specific, like if you want to know what the y-intercept was or the x-intercept is here, you can do your table of values. So an x and a y value. And so let's plug in, say, I don't know, let's start with -4 for x, -3, -2, -1, 0, etc. So if I plug a -4 in here, and you can try this on your calculator, -4 plus 3 is a -1. Log base 2 of a -1, you can't take a log of a negative number, so that one would be undefined. There wouldn't be a number. -3 plus 3 is 0. And can you take the log of 0? So to what exponent must you raise 2 to get 0? There isn't one. So that one doesn't work either. Dope. Okay, -2 plus 3 is 1. Log base 2 of 1. To what exponent must you raise 2 to get a 1? It's 0. That one's okay. Okay, -1 plus 3. If I put a -1 here, plus 3 is 2. Log base 2 of 2 is 1. And again, you could do those on your calculator. So for these points here, -3, there's nothing over, or for -4, there's nothing over there. -3, it can't be a number. But -2, it should be 0. Oh, I got that one right. -1 is 1. Oh, so that graph should have been up more like that. I didn't put a 0 in for x of 0, but that's going to be 0 plus 3 is 3. Log base 2 of 3 is 1 point something, 1 point something or other. So my graph should have been more like that instead of up high, but I was close. A couple things about that graphing. Notice that there's some values that don't work. And what happens in graphing for log functions is that this line here, it comes closer and closer to this vertical line, but never touches it. And this vertical line would be known as an asymptote. Okay, and you can graph it to find your asymptote, but you can also look at the function right there. So you want, anytime you're taking the log of any base of something in here, it can't be 0. It has to be greater than 0. So what you can do is you can say that thing inside the brackets, this part here, x plus 3, has to be greater than 0. So if I'm looking for the domain of the function, if I'm looking for all the possible x values, it would be this, x plus 3 is greater than 0, and then solve for x, it'd be x is greater than negative 3. So the domain is, as long as you have a number bigger than 3, then you're good to go. Another thing related to that equation there is this will also give you the equation of the asymptote. So instead of looking at the domain, what are your possible x's, you could say x plus 3 is equal to 0, solve that, and this equation of a vertical line is the asymptote. Okay, and that works for any of the questions. Like this one here, you'd say x minus 2 is equal to 0, so therefore x is equal to 2. That would be your asymptote. That graph would be moved over 2 to the right. Let me do that one in blue. 2 to the right, so the graph would look something like that. And that line there, x is equal to 2, would be your asymptote. Your domain would be x is greater than 2. So any number greater than 2 works. Okay, hopefully that helps you with that graphing. Here's a kind of log kind of question, and it's just basically a formula. So I need to use this formula here. They asked for the question in decibels, so that's the one with the 10 in front. And you just have to plug this in everywhere you see the intensity. So loudness is equal to 10 times the log of the intensity over some base thing called IO. So I'm multiplying, the intensity is this, so 10 to the 14th times IO divided by IO, and the IOs cancel. So now I have 10 times log of 10 to the 14th. Since it's base 10, the answer to this part here is just 14. And if you times that by 10, you get 140. So 140 would be the loudness of a jet engine at 100 feet. Hopefully that helps you with those couple log questions.